This lesson is on tree diagrams. Tree diagrams is one of the techniques that we use in probability when we're looking to figure out how many ways something can happen. For example, today at lunch you have a choice of a taco or a burrito. And with your entree, you get to choose one side item. You can choose rice or beans or a salad, and then you'll choose a drink, either water or lemonade. So what are all of the possibilities of lunch options? One way to figure this out would be to make a list, but a tree diagram can be a nice way to organize this information. We start out with what is the first thing we're doing. We're choosing an entree, so we're going to choose either a taco or a burrito, and we put these in our first column for our tree diagram. The next thing we're going to choose is a side item. With our taco, we can either have beans or a salad or rice. So this example here would mean a taco and then beans. This would mean a taco and then salad, and this would mean a taco with rice. With your burrito, you can either have a burrito with beans, a burrito with a salad, or a burrito with rice. Then let's go back up to the top. If we have a taco and then beans, we can either have lemonade with that or a water with that. So if we look at this first line, taco, then beans, then lemonade, that would mean we had a taco with beans and a lemonade. This order here means we would have a taco with beans with water. But before we do that, let's finish up the rest of our tree diagram. If we have a taco and salad, we still have the choices of lemonade or water. If we have a taco with rice, we also have the choices of lemonade or water. Same with burrito and beans. Let's give ourselves a little more space here. Then we can have lemonade or water with our burrito and beans. With our burrito and salad, we can have lemonade and water. And then if we have a burrito with rice, we could have lemonade or water. And then we can use this to make a list of all of our different options. We could have, if we go the taco route, we could have taco, beans, and lemonade, or taco, beans, and water. We can have taco, salad, and lemonade, or taco, salad, and water. And then the last option would be taco, rice with lemonade, or taco, rice with water. Those are all the options if we choose tacos. If we choose burrito, then we'll start on this top path, burrito, beans, and lemonade. Burrito, beans, and lemonade, or burrito, beans, and water. Then we have burrito, salad, and lemonade, or burrito, salad, and water. And then the last two I don't have quite enough space for. Burrito, we'll write them over here, burrito, rice, whoops. Now we're on to the rice one. Burrito, rice, and lemonade, or burrito, rice, and water. So now we know how many options there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We know there are 12 options, but we also know what all of them are. Making a tree diagram is helpful, especially when you want to know what the possible outcomes are. In this example, it says, what are all the possible outcomes if you flip a coin 3 times? Well, we know each time we flip, we have the possibility of getting heads and then tails. But when we talk about flipping a coin 3 times, we need to list 3 things. So for example, we could get heads, 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 or we could get heads, tails, heads. What we want to do is make an organized list of these. So we're going to start with a tree diagram. On the first flip, we could get heads, or we could get tails. So those go in our first column. The second column will represent the second flip. We could get heads and then heads, or heads and then tails. If we get tails first, we could get tails and then heads, or tails and then tails. On our third flip, we still have the options of heads and tails. So we could get heads or tails. We could get heads, 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 or heads, heads, tails. We could get heads, tails, heads, or heads, tails, tails. You see the options are the same each time. We have the same two options each time. So we have heads, 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 or heads, heads, tails. We can have heads, tails, heads, or heads, tails, tails. Those are all the options for what would happen if we got heads first. If we got tails first, we could get tails, heads, heads, or tails, heads, tails, 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 heads, or tails, tails, tails. So there are 8 outcomes, and this lists for us what they are. Sometimes in probability, they'll ask us questions like, what is the probability of getting 2 heads? And so we could look and say there's 1, 2, 3 ways to get 2 heads out of 8, so that probability would be 3/8. Sometimes it'll ask the question, what is the probability of getting at least 2 heads? So then we'd have to add in the heads, heads, heads. And so that would give us a probability of 4 out of 8, or 1/2. This is very nice if we want to see what the outcomes are. The last one I have here is if Sheila has 4 children, what are all the possible gender orders? So we could have like boy, boy, girl, girl, or we could have boy, girl, boy, girl. And if we wanted to make a list like this, a tree diagram would be helpful, but it's going to be kind of big. So we can either get a boy or a girl for the first child, and then for the second child we have those same options, boy or girl. If you have a girl first, that doesn't affect what you can have next. You can still have a girl or a boy. For the third child, the options are the same, boy, girl, boy, girl. Same thing down here. And you just notice that they get a little bit bigger. You see I abbreviated on this one. I didn't write out the words entirely because I knew the diagram was going to be so big. Boy, girl. In fact, it's going to get all squinched together, isn't it? Boy, girl. And we can use a diagram like this for so many reasons. It's really helpful when the probabilities get more complicated. When you're talking about having a boy and then a girl, the possibility of having a boy is 1/2, and the possibility of having a girl is 1/2. But what if we were talking about our kids being right-handed or left-handed? Then the probabilities change because you're not equally likely of being right-handed or left-handed. So having a tree diagram like this will help you set up those problems.